All right, so good morning everyone. Fantastic plenary speakers we had this morning. My name is Shelley James. I am the Secretary of Spnhc. I'm starting just a little 1 minute early just so that I can go through a few little things so I don't cut into Alexander's time in the first talk. Welcome to the 40th Annual Spnhc Conference. This session that you are seated in is CTRB03.1 to be precise. Contributed session, Digitization, Data Management or Data Integration. Oh, I'm passionate about this stuff, I tell you. Yes, and I'm Shelley James, and we have Samantha helping out as well with the microphones. So for our speakers, you have 15 minutes total, but we need a bit of a changeover, so I'll give you sort of eye contact at 7 minutes, 9 minutes, and then the 10 minutes I'll sort of do the old, you're ready to roll. And then that gives you a little time for questions and for the changeover. So thank you everyone for coming along. This is being recorded, so thank you very much to all of our online viewers too. Hello at home. Glad to have you join us. I will try and monitor the online chat, but we'll see how we go with that with my dandy phone. We'll see what questions pop up. Please raise your hand, use the microphone if you're in the room, if you have questions. All right, so we'll enjoy the session. First up, we have Alexander will be speaking about verifying natural collections.
I need a little assistance here.
I don't know what's happened. I'll leave it to the tech guys. They're marvellous. We love them.
So, hello everyone. My name is Alexander Wolotkin. I'm from Senckenberg, Germany, and here I work on our project BITS, Blueprints for the Integration of Terminology Services in our System Science. Today I tell you some hopefully interesting facts about verifying natural collections at Senckenberg, especially natural collection at the edge. And we will take a look at a very small introduction. There are some backgrounds, and after we take a look at our solution approach and technologies. Then we have a little time for outlook and discussions, and we start just to get a better overview about our current state with some facts about Senckenberg. Currently we have around about 40 million up to 45 million physical specimens there, and there are around about 1.5 million digital specimens in different collections and scopes. You see there is a huge gap we have to close, and also we have to handle some entries like mixed languages, taxonomical structures in object descriptions, but also various image data, and currently it's actually about a plain text user interface without some fancy widgets or linked data. So we have to handle some challenges there. It's about continuous graph of collection data. We have to verify faster than our collections are growing right now. There is a lack of human resources. On the one hand, there are no humans available. On the other hand, there are no funds to pay them. On this way, we have to use some AI or automation solutions for that. There is also a lack of specified informations. That's the problem because currently, due to this, we are not able to train some specific models for our collections. And at first, we have to build a kind of a basement due our collection data. In later steps, we will deliver some data to data aggregation platforms like JBIF, but currently we have to specify some needs and data models. Right. There are some infrastructures in development. Currently we are working on a new CMS, DINA, and some parts of the FDO, Fair Digital Object Infrastructures, are already available. But what is about the fairness? The FAIR principles are central to research and project funding in Germany, in Europe, and if there is a proposal, often we have to require fairness of the resulting data of our codes. Also, we are a member of the German National Research Data Infrastructure. I think we can skip the rest because we don't have a lot of time. And here you see an example for our data collection workflow. So we have to annotate our data. And to the left, you see an example for a habitat description. There you see it's not about any kind of everyday conversation. It's more about scientific terms and more shorter structures. So in a way, we have to handle this. In the current state, you see there are no semantic informations, and due to this, there are some difficulties to find our entries. There is a limited accessibility and reusability, and actually our data are not really interoperable right now. This way we have to clean our data, and then there is a question how to annotate them. What kind of text, what kind of chunk of the text we have to annotate. In our opinion, it's about noun phrases, noun groups, subgroups, single nouns, and we have to detect them. We can do that using Spnhc. Maybe someone know about that. But unfortunately, it's not really reliable this way. So we have to use some external AI services. And on this way, we have also to take care about the privacy. In later steps, you will see that. After, we have to merge our noun groups, noun phrases, and indeed, it's much more easier to do that in a manual way, so on a desktop computer or something like this, not due to any AI service. And then we have to annotate them with bits. Like I said before, it's about our terminology service. To the right, you see some entries, how we can annotate our data. And actually, it's about an automated annotation. But indeed, we need some outputs. We need some user interfaces to take a look at the AI imagination of our needs and the responses for that. Here you see our system processing sequence. There is a lot of technical stuff. We can skip that. Actually, currently is important to take a look at the processing, at the text processing and data annotation. Text processing, like I said before, we can use various AI services. They will be used at the edge, so it's about last mile computing. And then we have to annotate our data sets. It's another one challenge. And we have to ensure compliance with privacy and also with data requirements under the European Union Artificial Intelligence Act. So currently it's better to work at the edge. Especially, of course, we have to publish our data, but we have to do that after publication. Before publication, we cannot provide our data to anyone's service like ChatGPT, DeepSeek, or something else. So we have to use our localized computational resources. Anyway, if there is an external service, we also have to take care about the external operating and running costs. And currently we are working based on a very mobile, very simple one hardware solution. It's about the NVIDIA Jetson AGX Orin. So we can grab them, you can take them with you in a train or something like this. So it's really nice to work with them. There we have enough RAM to try out various AI models, but of course it's not the perfect one solution to annotate a huge amount of data. For this, we will build another one node for AI-based annotation. Currently, it's only about the development process. Here you see our model configuration right now, and like I said before, there is a lack of logical abilities in merging results, so we have to do that manually. Here we have to describe what's the role, what is the format, what should be displayed at this step, and we also use a temperature volume of 1 for more creativity, and reasoning effort is high. So, what's the outlook? Currently, there are two important parts. At first, we have to harmonize our data streams, and due to this, we are working collaborative on the DINA development. Also, we have to use some flexible data models. We have to include our automated annotation processing and also human-created data. And in the future, we also have to handle our visual data. So currently we are working on some multimodal AI models. They are being tested, and currently the results are really great. So, thank you for your attention. I hope I'm good in time. And if you have any questions, feel free to ask. And if you have more questions, we can come together in later steps. So, any questions?
Does anyone have any questions?
Yeah.
So are you training, you're saying you're training your own?
Sorry.
Oh, sorry, my name is Nick. Thank you for coming to talk. I'm just wondering if you're training your AI model on the hardware specified with, or you're running a local version, not using web calls.
Currently, we have to use our local models, but unfortunately, we cannot train them due to lack of the really high quality data. So at first, we have to generate this data. And that's currently the problem because there is still human in the loop. We need some human power to annotate or to re-annotate some data. And after we have a basement, we can train our own models. But in front of us, we have to generate high quality data. That's the current problem.
Any other questions?
Oh, yeah.
Oh, good.
Okay, thank you very much.
Thank you.
If we do have plenty of time.
I think it is.
Just very quick question. So I'm just kind of curious, like, why not maybe do it the other way around? So where you have the verbatim data just as it is and then search for those things versus using this to parse a priori?
The problem is, on the one hand, there are humans, they are searching for data, but in our case, it's more about the AI agents. So we have to interconnect our data in Germany in our NFTI network and other networks, and on this way, our data should be interoperable for AI agents too. So you can perform some searches, but you cannot be sure about the semantic meaning of the data you would get on this way. It's like Google right now. You can ask Google, but you can ask also ChatGPT or something like this. And there is a difference between the semantic meaning of data.
I'm just trying to get online. Sorry, everyone. Didn't update my tech. Zoom wants to update for me, just to see if there are any questions online.
I'm online now.
There's nothing at this point? Okay.
Okay.
Well, we'll just hang tight for just another couple of minutes, just because we need to keep on time, and you were super early, so we'll do a little interpretive dance.
So.
Well done.
Okay.
Oh, good. Thank you. Thank you. I'll have to leave all the online stuff to you. Yay. All right, up next we have Ed Gilbert. You want to come up and get yourself comfortable, you know, pour yourself a glass of water, do the little interpretive dance.
Okay, so how do you open the presentation?
I'm not sure. How do we go to the next presentation? Sorry. We had such a short break that I didn't have enough time to get savvy. Yeah. Speak in the microphone because...
So there's a tab here with all the presentations.
Okay.
So these, that's the right one.
That looks it.
View.
All right. So
Good.
I think far away.
Okay. Good morning. I'm going to talk about how you could outsource specimen digitization into a Symbiota portal, so move it out of doing your collection into a collaborative portal. All right, so Symbiota is a software that's available on GitHub. You could download it. So a project that contains a bunch of different collections and so forth. They could download the software, load data in there from multiple collections, modify configuration files, CSS files, and it will establish a collaborative portal where you could do your digitization, and all based on a certain theme that represents the research community. So here's an example of taxonomic portal. That's the Myrtaceae, American Myrtaceae. That's the lichens of the world. But also you could have a geographic theme involving, here's all the specimens across all taxa within Guatemala. This is all the specimens within Gabon. Or you have a project portal. This is a portal that's used to manage all the specimens that are being collected part of the NEON project. And here's a Smithsonian Panama portal. And then this is a portal that's specific to a project that's on a research station off Panama. Not Panama, Florida. So all the data within the portal, you import it from multiple collections, but all the data could be managed directly within the browser. There's a lot of benefits of managing data within the browser. It's platform independent, globally accessible. Instead of having your digitization team having to come in the collection, it could be done from anywhere, their dorm room, when they're on vacation, etc. Anywhere from around the world. So in 2011, NSF established a digitization initiative called the Advancing Digitization Biological Collections. It was established by the Obama administration, and it was a 10-year period. And in part of this initiative, they would award 2 to 4 projects per year. Each of these projects was a collaboration of multiple collections, anywhere from a dozen to some of the TCNs, they were called thematic collection networks, involved 100 different collections. So, and some of the early on digitization projects that were funded, they adopted Symbiota as to install as their digitization hub. And one of the workflows that was established early on was what came to be known as an object to image to data workflow. And the goal was to go into each of the individual collections, image all the specimens as quickly as you can, including the labels of the images, and then upload them to a web server, integrate them into the data portal, and then you could start doing the digitization through the data portal. And here's an example of one of the tools that was built. It's a data entry form where you could pull up the label, and initially that form would be blank. And then you pull up the label, and you could use OCR, natural language processing, to transfer the information that's in the image of the label over in data entry form. Now, one of the benefits is, you wouldn't have to have the data entry team handling the specimens. They could just do it right online. As the years have gone by, 2/3 of the digitization projects would incorporate a Symbiota portal into the workflow. Now, I want to emphasize that each of these data portals, it's an aggregate, mid-level data aggregator of multiple collections. And there are some collections would be imported in there from an Excel spreadsheet or homemade database, and then they can manage data directly within the portal. Other collections would integrate data snapshots from data that's being managed in EMU, Specify, Arctos, and then they could do digitization there and then get the data back. Now, one of the benefits of doing it in an aggregator type system is like that, you could develop these workflows. Oh, it's not highlighting the stuff correctly, but you could digitize these workflows where you could do crowdsourcing. So now you could have these crowdsourcing volunteers to create accounts in the portal rather than creating accounts across all the collections. It's just in the portal. And then the collections that want to participate in the crowdsourcing, they decide what specimens that need to be processed that are submitted to the crowdsourcing module. And then there's an annotated form that's highlighting just the fields that you really want the crowdsourcing team to focus in on, and that's where the digitization is done. Now, another benefit of doing it with an aggregator system like this, within Herbaria, specimens are collected in duplicate. So people will collect a specimen, they'll deposit it in their home institution, and then there'll be enough specimen data to actually go to other institutions. So in this example here, you have a specimen that's stored in Cal Poly, but there's 5 duplicates in 5 different institutions. So it's the same data, same specimen, same collection data. It was all collected by the same person on the same day. Now, the benefits of networking, creating these duplicate clusters, is when you're doing data entry, you have a form here, you have the image. There's no data in there, but if you enter the collector and the number and or the collection date, now you could search the system. You could click that duplicate button to search the system, and it'll look to see if that specimen, one of the duplicates, has already been digitized. If it has, why digitize all 6 of those duplicates separately? Instead, you could just click on the transfer button, and it'll pre-populate your form. You review it, you enter your catalog number, and you're set. So another benefit to networking these duplicates, creating these duplicate clusters, is it could help you and actually fix misidentified specimens. So now we have a sample here that's, again, in the San Diego Museum, and it was identified to Lupinus cassineus. And however, after it was collected and deposited there, 2 of the duplicates in other institutions were annotated by different taxonomic experts to Lupinus arizonicus. And so this indicates that perhaps this specimen, this duplicate, needs to be annotated. There's also data cleaning tools that are built into Symbiota. So here's an example of a tool that goes through the names, the scientific names that are associated with the specimens, and it compares the names against the taxonomic thesaurus. If it doesn't quite match in the thesaurus there, it highlights it, and it looks for best matches. So here we have a sample where there's 7 specimens across multiple collections. And so there's 7 specimens associated with that misspelling. So what they can do is you just click there, and then it fixes all those specimens at once. So it also runs, as it's running through the names, perhaps the name's not in the central thesaurus. It actually sends the information, uses the API that's associated with Catalog of Life, and it'll send the name there. If it's validated, it'll update the thesaurus and link those specimens to the correct name. So, and I want to emphasize that you could do this across multiple collections. So rather than doing this data cleaning with each individual collection, where you're fixing the same mistakes multiple times, it could be done all at once. And the same thing can be done with georeferencing. You could have a list of the occurrences there. There's a tool there that lists all the localities. And you could go through there and select the localities that are essentially the same, but they're just spelled differently or rearranged differently. The number in the brackets to the right there, that's the number of specimens that are associated with that. So sometimes you could have like 10 specimens that have the same locality. You select them, and then you could assign coordinates to all those specimens at once. And again, you could do this across multiple collections. So rather than georeferencing the same localities multiple times across multiple collections, it can be done a lot more efficiently. So then there's interoperability built into geolocate. So for instance, let's say you have a bunch of researchers that are studying oaks, and they want to georeference all of your oak specimens because they want to use it in research. But they're not part of the digitization project. Well, within the control panel, you could define, go to each of your collections within the portal. You could define the all the specimens that are oak. In this case, it's 240. And you could select a project that's in geolocate, so a different application, and it's web services that are built between the two products to do the communication. You select the geolocate project, and you could submit the data into that project. And then that team, that group of researchers, they could actually do the georeferencing through geolocate. And as they're georeferencing the individual specimens, the data immediately flows back to the specimen and keeps track of who did the annotation, when they did it, and so it could be reviewed by the collection manager. Now, I mentioned before that within these portals, there's a group of collections. Some are live managed directly in there, and in those cases where these edits are done, everything's fine. That's their central collection. But what if you're doing a situation where you imported data from a specified database or another database? You have to get it back to your source database. And that's where the big challenges have been. However, the system does keep track of all the edits. So it keeps track who made an edit when, what field was changed, the old value and the new value. So not only per record change, but per field change. And this data could be downloaded as a spreadsheet or a printable report, or it's also available with an API that's integrated into the system. So these other tools, data management tools, they could actually build the tools to query this data and integrate the data back into their central database. And so it's available through the API as a JSON object. So, and these interoperability is something we're really working to push, and so that other collections make use of it. And this is the whole developmental team that's available now. Did I do well? Time-wise?
Thanks, Ed. We have time for just one question. One question. Or maybe two.
That's okay.
You mentioned that's a crowdsourcing project essentially for fixing errors that you're finding. How do you verify the credentials of the people? Like, is that listed when you say name of editor? Does it say this person knows what they're talking about? Or is it just students in their dorm room who could be doing anything?
That depends on the individual project that installs the portal. So usually, so the crowdsourcing tool, it's anyone that creates an account within that portal. And that way they could track who is there and so forth. And there's a control panel, and it does the reviews, and you can assign points to people and give input. And if you have a situation where someone is doing a lot of errors and stuff like that, you could remove those permissions. But it's controlled by the portal, and they have to do the training. People that establish the portal, they set up the groups, they do the training, and then the collection managers and the portal managers do the monitoring too. So.
Anyone else?
Hi, fantastic that you can copy when you've got duplicates. We find with our historic ones, whilst they are technically a duplicate, the data can vary ever so slightly. So are you able to then make additional changes to that individual record if there's that slight variance between what label transcription you've got? Say 90% is the same.
Yeah, that's why it's done per record. So you do it per record. That way you could review it, make any edits as you want. And it'll list all the duplicates. There's a lot of collections out there that don't have exact specimen duplicates like the herbariums do, but they have the same collection event. So that could be useful too. So if you just enter in the date and the name of the collector, and you have a collection event, it will just import the locality information and the event information, but not the collection specific stuff. So,
Okay, thanks.
Sorry.
I'll be around if anyone has questions.
Yes, please see Ed, during the coffee breaks, lunch. Yes, thank you, Edward. And I do apologise for finally getting my tech to work and then demonstrating that the sound is clearly working. So I do apologise for that. So moving on. Oh, escape. Let's see. No. No. Too loud to preview. Do we need to download it, or magic of technology is about to be resolved? But tomorrow I'll have this down pat, and then I'll be leaving. Yeah.
Let's open up the next one ahead of time.
All right. So next up we have Julie Winchester, who's going to be talking about MorphoSource. So welcome, Julie.
Hi, everybody. Thanks, Ed, for that talk. That was great. And I'm actually really happy to talk after Ed talking about Symbiota, because I'm going to talk about a resource that I think complements I believe, Ed, your level was mid-level aggregator and collection management system. I'm going to talk about MorphoSource, which I think complements that sort of thing very well. So I'm Julie Winchester. I'm the technical director for MorphoSource. And I am going to talk about what is MorphoSource. I'm going to sort of tell you a little bit about the platform, and then I'm going to talk about some of the features that we've added to the site recently, including one that we are very excited that just went live a couple weeks ago. So just to start with, what is MorphoSource? This is my elevator pitch. MorphoSource is a digital repository service where researchers, museum curators, and the general public can find, download, and upload 3D specialized, but also 2D and AV media, largely representing objects of academic or scholarly interest, but also some born digital creations. Tell you a little bit more. So we are a publicly accessible web repository that is free to access, free for users to download data, and for users certainly with less than 100 gigabytes of data, it's actually also free to contribute to. We are 3D specialized, and the data are all contributed and managed by a user community of scholars, researchers, museums, institutions, imaging facilities. Yeah, so those are our main user communities: researchers, museums, and imaging facilities, and the general public. And really, I should probably have a fourth bullet point in here for educators. We have a lot of K through 12 educators working with the site. My phone thinks that Siri got activated. The things you can do on MorphoSource include data discovery, data access through downloading, or we think, because 3D data often require very specialized, you have to have specialized software to work with it, especially for CT stuff. We have a full-featured web viewer that you can interact with the data. You can measure things in it. You can contribute and publish data for either as part of a museum collection or scholarly publications. And museums and facilities can actually use MorphoSource to track and manage scans, so they can use it to manage scans related to their collection. Some historical facts and figures. We got started in 2013, so we've been around for about 12 years now. We are organizationally a part of Duke University, though we also have some representation here at KU. I'm a KU affiliate. I live here in Lawrence. Yeah, and we have about 220,000 3D media files representing 78,000 physical objects from over 1,600 organizations. That's over 1,600 museum collections, university departments, imaging facilities, where around 230 of those museum and collection teams are actually participating on MorphoSource, helping to track and manage their data, helping to track the impact of their data, helping to curate their scans. MorphoSource supports a lot of different media types, 3D meshes, your 3D image stack. So we have heavy support for CT image series, but we do also support actually photogrammetry image series and histological slide sections. And as I said, 2D images and video as well. We talk a lot about media modalities, the different ways that a media is created. We support a lot of different media modalities. I think some of the most popular on the site are X-ray, micro, CT, photogrammetry, structured light, photographs. Some of the things that set Morphosource apart from some other resources is there is a strong emphasis on modeling complex imaging workflows. That sometimes you have imagery, especially 3D imagery, that go through a complicated process of different software and different processing steps. And Morphosource allows you to document simple or sometimes complex workflows of imaging and processing using sort of an entity event model. All the boxes on this diagram are sort of different records. Each of these records have their own metadata. We also have a museum-mediated flow of data, where media get linked to a physical object record. Those object records are linked to museum-published records and synced through aggregator resources. And museum collection and imaging facility staff can obtain elevated access to their objects and track the impact of how the collection's things are being used, even if it's third-party researchers that are uploading those materials, say, for their research projects. Morphosource is actively used. This is just a graph of our downloads and our views quarter by quarter, which we got a big lift in some of these. You may have heard about the OVERT project, in which many different museums, including KU, participated to scan a huge quantity of vertebrate diversity. Yeah, the down for the views, I always have to specify, we had a bit of an outage where there were a few weeks where our views weren't being tracked. If it wasn't for that, it would probably not have been down that much. But, and also, you know, I will humbly suggest that Morphosource, among comparable resources, is the most frequently cited in scholarly publications. So we have tracked over 2,700 citations that are linked to Morphosource datasets, over 100 of which are theses and dissertations. We have a wide taxonomic breadth, so especially if you just look through that list of publications, there are publications on almost all realms of eukaryotic life. And I will say, although OVERT has had unprecedented impact, it actually represents less than 10% of all media on Morphosource. We also facilitate a lot of grants. We have been able to track over 220 unique NSF grants that mention Morphosource or use Morphosource in their data management plan. We were mentioned in over 75 public NSF grant abstracts, and those awards are separated across geology, biology, social, and behavioral. Just to show you some things we have on Morphosource, we have photogrammetry scans of insects. We have scans of flowers. We have scans of echinoderms, such as this lovely crinoid that comes from the KU Invertebrate Paleontology collection. We have protozoa, and we also have cultural heritage objects. That's a thing I like to point out, that Morphosource also supports non-biological cultural heritage objects as well. Okay, so that's my what is Morphosource. If you have seen a Morphosource talk before, you can maybe stop taking your little micro nap. And I'm going to talk about the things that we have done, especially in the last year. So this is just a little overview slide of some of the stuff that we have worked on in the last year. The little background, that's actually our GitHub commit records since last May. I like to call this the nerd slide. These are all the things that we do in the back end that if you come to the site day to day, you would not know about. So summer we moved to Kubernetes. Basically lets us, if you look at this little diagram, every one of those circles is a little like container. It's like a microcomputer that participates in the octopus of terror that is our infrastructure. But it allows us to scale in response to load. We're also working on software improvements behind the scenes continually. And in mid-May, if any of you run any digital resources, you may have experienced in the last year, the small internet has been inundated with distributed bots working on sort of training AI tools. And we actually just added bot blocking, where we are letting the bots go in the doors we want them to go in, because we do want them to be able to scrape some things, but we don't want them to scrape other things. But none of that was a security risk. It's more just that if you go to the search interface and it has all of those like ways to filter your search, bots get trapped in filtering the search in the million combinatorically possible ways of doing the search, and that's not helpful to them. It's not helpful to us. So that's basically what we added the blocking for. For directly managed collection organizations, we made some changes to how this worked. We used to have this concept called you had an organization record for your museum collection and you had a team. Now they're the same thing. Now users can, staff from a museum can have a Morphosource account. They can become a member of a museum collection on the site, and they can track and manage their media on the site. So they can specify their recommended ownership and permission settings, and there's also a workflow to automatically take over long-term management of media after those media are published. For imaging facility staff can also sort of track media scanned by their facility on Morphosource. They can also track some of the stats that are most important to imaging facilities, like the number of imaging events. You know, how many times was this CT scanner used for media that are on Morphosource? And they can manage device metadata. So I have UT-CT facility here on Morphosource. It's just an example of one of their device pages showing you all the scans from one of their CT scanners. And these are the facilities that are currently managing media on Morphosource. All right, if you have gone to our search page or look at our project pages recently, you may have noticed that there are 2D image previews for 3D models where previously some did not exist. So we have started automatically generating 2D. If you upload a 3D model to Morphosource, we automatically generate a 2D image preview for you. You can also upload a custom one. And this is some stuff we've just started working on. IIIF. So IIIF stands for International Image Interoperability Framework. It is a community standard for presenting open imagery and annotation. It is already used by many museums, libraries, universities, and IIIF 4 is coming, like next week. We are going to release the draft of IIIF 4. I'm also specification editor for IIIF, and one of the things that's going to have in it is IIIF is now going to have deep 3D support. And so we use IIIF pretty heavily on Morphosource. Our viewer is IIIF based, and all of our preview assets are backed by IIIF manifests. And yeah, so we put support for IIIF 4 live in mid-May, which means that basically resources that are mobilized on Morphosource can be consumed by IIIF viewers elsewhere. So it allows this stuff to be transportable between resources. And you know, one of the things that this really helped us to get there with is we just added a new 3D viewer. So just to show you a new 3D viewer, I have a mandible of a whale here just for examining some of the new things this viewer does. It has orthographic and perspective cameras. I know that orthographic cameras are very useful sometimes for research use cases. We always had the ability to take length and angular measurements on models, point on a model to another point on a model, but we added a new measurement method called like screen ruler method. Imagine just putting a ruler right on your screen, which sometimes is a little more easier for lengths. You can also access general object dimensions through the bounding box. We have rotations and lighting control. And the last thing that the new viewer and IIIF 4 got us, this will be the last thing I go over, is, and we just unveiled this a couple weeks ago, you can now tell stories with annotations on Morphosource. So you can save and persist annotations that automatically display on the media page. If you have media on Morphosource, the way that you get to this, if you have a 3D model, it's limited to 3D models for now, if you go to your media edit page and you go to the new preview tab, so it says beta up there, it'll let you export and save annotations and initial model rotations. Sometimes you upload a model, it's like upside down or backwards, so you can fix that now. The annotations, they have titles, they have descriptions. Annotations have a specific camera view, and users can step between annotations smoothly for a narrative experience. Let's see if this ends up working. Yeah, so this is how a user might step annotation through this model. And because I don't have a lot of time, I will just note that all of these annotations, these are backed with IIIF manifests. So these annotations are openly transportable, they are interoperable, and they can be viewed in other IIIF compliant viewers once more people build them. But Smithsonian Voyager actually over in the IIIF Slack just unveiled their sort of work in progress support for IIIF as well. So you'll be able to take annotations from this and use them in Smithsonian Voyager. And as one last thing, because there's been a lot of concern from people that have things in Sketchfab, where maybe people have put a lot of annotations on things in Sketchfab, and Sketchfab may be going away, you can migrate annotations from Sketchfab to Morphosource. We've put up this little tool that'll actually You can use it to get Sketchfab annotation JSON off of your Sketchfab models, even for any purpose. It'll give you the Sketchfab annotation format and convert it to the Morphosource format. And that's all. Thank you very much.
Thanks very much, Julie. We actually don't really have time for any questions, so
Well,
I will.
I will be around.
Yeah.
And I have stickers. I have Morphosource stickers.
Stickers, stickers. Everyone loves a sticker. All right. And last but not least, for this session, we have Timothy Diamond. I can't talk and navigate at the same time. Where's the... I don't use this very often.
Slideshow.
Oh, the big button up the top, Shelley. Hello. And there we go. Welcome, Timothy.
Hello everyone, my name is Tim Diamond, and this presentation discusses a research paper I did at Johns Hopkins University in 2022 for improving biodiversity data standards. Changes in technology, classification systems, and personnel can make data inconsistent and less valuable. With that, this research is intended for collection and data managers, along with natural history listserv groups, to get ideas for improving their biodiversity data. The guiding questions for this research paper were the following. 1, what developmental frameworks are most efficient in cleaning and refining biodiversity data? 2, what functions and technology are helpful in cleaning biodiversity data? And 3, how best to enforce data consistency and quality standards across collections. This presentation breaks down the research process, institutional findings from 3 different museums, as well as an analysis section, conclusions, and next steps. The research design of this paper had 3 sections: the literature review, the survey, and the interview. For the purposes of this presentation, I'm not going into detail on the literature, but I will overview the other 2 sections. Section 2 was the survey, as shown with the questions on the left. The survey's goal was to highlight what the museum is doing in terms of improving software, use of existing tools such as controlled vocabularies, and training resources such as workshops and workflows. Section 3 was the interview, as shown with the questions on the right. The interview's goal was more in-depth responses that assess the pros and cons of institutional features in place and how the museum is actively addressing them. Eventually, based on the responses received, surveys and interviews were conducted at 3 different museums: the University of Wyoming Museum of Vertebrates, the Bernice Pauahi Bishop Museum in Hawaii, and the Smithsonian National Museum of Natural History. The respondents were Dr. Elizabeth Womack, Dr. Richard Pyle, and Adam Manser, respectively. Dr. Elizabeth Womack is the staff curator and collection manager at the University of Wyoming. Her responsibilities include collecting and processing specimens, curating the collection material, and teaching students and volunteers. Womack really emphasized the usefulness of the Arctos database in her answers, describing it as being flexible, accessible, and collaborative. Being an online database, it can manipulate controlled lists and taxonomies across multiple institutions, creating a more holistic data practice. Feedback and improvements within Arctos software is driven by all museum members that use it through monthly meetings. Active guidance and teaching was emphasized for students and volunteers. For students, they are trained in data standard tasks, starting at individual data entry that progresses into bulk uploading. For volunteers, data standards aren't as actively enforced. Instead, they're provided as a resource or teaching tool that helps educate said volunteers while also enriching their understanding of the institution's responsibilities. Dr. Richard Pyle is the Senior Curator of Ichthyology at the Bishop Museum, as well as its data contributor and data aggregator. Pyle discussed using in-house tools optimized for physical and digital collection management. One example being agent name parsing, which creates a huge index of database names for staff members to choose from. This example aligns well with his quality assurance response, which selected data consistency, as there is a significant amount of time spent transforming data into standardized values. Workshops were selected by Pyle for improvement measures, emphasizing that he feels that they're more focused than conferences and meetings. Discussing volunteers, Pyle mentioned how many of them are retirees that really invested themselves into the process, and to maintain those quality standards, Pyle wanted to create incentives for them. These include dashboard milestones leading to rewards, as well as timestamps and activity logs to increase the volunteers' awareness of their value to the institution and gain recognition from staff members. Future plans include a dedicated informatics team to homogenize their scattershot in-house data templates from the past. In addition, they were actively investigating a different database to use, this one being EarthCape, which is optimized for custom data entry methods and data modeling, making it ideal for the Bishop staff to adhere to their past data entry forms. Adam Manser is the IT specialist and data manager within the Smithsonian's Mineral Sciences Department. His responsibilities include working in the EMU database, importing, cleaning, and enforcing data, and working with all staff on museum-wide data initiatives. And yes, as Manser also said, this is technically not biodiversity, but the same principles apply to his position. Manser discussed using Python, the open source computer language, as it has greater flexibility over EMU in creating easily readable data. Dublin Core, Darwin Core, and Biological Collection Access Service function as custom schemas that are mapped into the EMU database, along with his preferred vocabulary preferences, controlled lists, and authority files to help further navigate EMU's complexities. Staff meetings and training sessions were selected by Manser for improvement measures, emphasizing that they yield fast and direct benefits. Discussing volunteers, Manser said you can't force them to do something they don't want to, and that work review measures and detailed instructions for them are also needed. Manser cited an increased difficulty in data standards since the pandemic, with a greater reliance on remote entry and database work. And so, with the overseeing and coordination of collection managers and contractors, Manser concluded that he wanted to develop more templates. And as of June 2022, a task force was developed to help consolidate workflows across all departments. In addition, in-house development, such as 2-week sprints, were suggested to test and refine data efficiency measures before fully implementing them. Based on this data, we can pinpoint some broad answers to our main questions. For questions 1 and 2, we have customizable databases, programs, schemas, and controlled list vocabularies. For question 3, we have quality assurance measures, volunteer engagement, training sessions, and consultation measures. Assessing trends on a technology side and a human side with biodiversity data standards. Our first 3 points show that we need databases, schemas, and functions that creates data that is easily transferable and minimizes room for errors or complications. Our next 3 points show that we need learning and improvement measures that emphasize accessibility, timeliness, and giving a voice for all staff, volunteers, and contractors. Assessing the technology and human side again for overall recommendations. Our first 3 points show that we need to assess technology on a methodical level, with feature-rich databases that have seamless and accessible programming that help staff adhere to their data standards while also gradually testing it before fully implementing it. Our next 2 points show that we need text-based and communication-based resources to help all museum members realize their own potential within the institution. For next questions and steps within this research process, one angle to take would be research on applications for commercial software, such as OpenRefine, and how staff members utilize it. In addition, we could discuss financial constraints, funding and grant sources, and the needs of other stakeholders, and how these factors affect other institutions' efforts in increasing their own ideas to progress biodiversity data refinement. Thank you for listening. Do you have any questions or additional thoughts or comments?
Thanks, Timothy. We have 5 minutes for questions.
Yeah.
Hi, that was great. I love
Hi.
that you took that on. I'm curious in the conversations if we can say that the cheapest data, the highest quality data, is when it's collected in the field to start with. So did any of them bring up that sort of bringing the data in the first place and what can be done at that level to improve this process, as opposed to capturing legacy data that's already on a label?
So one of my, I didn't go into it, but one of my pieces in my literature review was, it was from, I believe it was from Elzen Turnhout, and the idea is that she talked a little about proactive digitization, and the idea is that within the field, they would go out and take samples and inventories of one data and basically share it with other members as the template moving forward with other repositories and collections. So there's a bit more detail on that within my paper, but that's sort of a guiding template that could be talked about.
Cool, thank you. Yeah, for a forward-looking
Yeah.
collections. Yeah, thanks.
Anyone else?
Any other questions?
Is the original data from the surveys and stuff online or available?
They're all summarized within the paper, but I think I do have records of it if people are interested at all, so.
Any other enthusiastic questions before you all head off for lunch? All good? Well, thank you, Timothy. That was great.
Yeah, thank you.
So, yeah, thank you to our 4 speakers for this morning, and thank you all for coming.